Hello class, today what we're going to look at is solving logarithmic equations. And solving logarithmic equations is pretty much the same thing as solving exponential equations. We're just taking them the other way around. So here we have this property of equality for logarithmic equations. And what this says is that if you have log base b of x equal to log base b of y, then x must equal y, right? Because if the bases are the same and the logarithms are the same, the arguments must also be the same. So if log base 2 of x equals log base 2 of 7, then x must equal 7. All right? It's pretty simple. All right? Let's take a look at problem A here. The natural log of 4x minus 7 equals the natural log of x plus 5. All right? Now, if you'll notice, these are both natural logarithms. So these are both log base e. They have the same base, so the arguments must also be the same. So 4x minus 7 equals x plus 5. Subtract x from both sides, add 7 to both sides, divide by 3, and x equals 4. All right? So pretty simple. We can check it over here. If we take 4, plug it back in. 4 times 4 is 16, minus 7 is 9. 4 plus 5 is 9. Natural log of 9 equals natural log of 9. All right, so we see it works, and it's good. Now let's take a look at problem B. Log base 2 of 5x minus 17 equals 3. All right, so let's write down our problem. Now this one we don't have logarithms on both sides of the equation. So they're not going to have the same base, so we're not going to be setting arguments equal to each other. Instead, what we're going to need to do here is work this out, get rid of this log base 2. And the way we get rid of this log base 2 is we exponentiate it, which means we're going to have 2, and we take all of this and we make this an exponent base 2, which is the base of our logarithm. And if I do this to the one side of the equation, I got to do it to the other. So this becomes 2 cubed, right? Now, if your exponent and your logarithm have the same base, they cancel out and go away, which just leaves us with 5x minus 17 equal to 2 cubed, 8. All right? Now, another way we could do this, we could kind of bypass this whole step by writing this as an exponent in exponential form. So we just have 5x minus 17 equals 2 cubed. All right, a little bit quicker. And now we have this nice little linear equation. We can solve this. Add 17 to both sides, divide by 5, x equals 5. Plug this in to check it back into your original. And now with logarithms, you got to be really careful because remember, a logarithm cannot have an argument that is negative. Can't take a logarithm of a negative with a negative argument. So we plug that 5 back in. 5 times 5 is 25, minus 17 is 8, so we're okay. This is not negative, it's positive. And does log base 2 of 8 equal 3? Well, let's rewrite it as an exponential function. Base is 2, exponent is 3, argument is 8, so 2 cubed equals 8. Yeah, 2 cubed equals 8, so this checks out, this is good. But you do need to take these and plug these in, especially when you have some minus stuff going on here. If you have negatives, you need to plug that in. Make sure that the argument comes out as a positive. If the argument is positive, probably okay. If the argument comes out as a negative, though, it doesn't work. We cannot take logarithm of a negative number. So let's take a look at this one. A little bit more complicated because we have two logarithms on this side being added together, and we have this 2 over here. So I couldn't just move this over because I'd have a 2 in the way. Now, if you'll notice, our logarithms are both common log, right? Common log of 2x plus common log of x minus 5. So our bases are the same. If our bases are the same, we can use those logarithm properties we learned about in the previous section and combine these into a single logarithm. All right? So what we're going to do here, since we're adding the logarithms, we can multiply the arguments. So this becomes common log of 2x times x minus 5. All right. Going to go ahead and exponentiate that. Get rid of the logarithm. Gives us 2x times x minus 5 equals 10 squared, or 100. So basically just writing this in exponential form. Need to distribute that in. So it gives us 2x squared minus 10x equals 100. Now we have a quadratic function. And so we need to solve this quadratic function. Step 1, we're going to write it in standard form. Set it equal to 0. So subtract 100 from both sides. Now we want to factor this. The easiest way to solve these. So we're going to factor it first by pulling out the GCF, which is 2. So we divide that whole thing by 2. 2x squared divided by 2, negative 10x divided by 2, negative 100 divided by 2, 0 divided by 2. And now we're going to factor it, which is x minus 10 times x plus 5. So that means using the zero product property, our answers are x equals 10 or x equals negative 5. Now, all year long we've been seeing this. Anytime we have two solutions, we need to plug those back in because half the time one of them doesn't work, right? So we got to take these, plug these back in, and we'll take a look at it. So let's try 10 first, because that's the first one there, why not? So common log of 2 times 10, plugging the 10 in for x, plus common log of 10 minus 5, plugging 10 in for x. 2 times 10 is 20, 10 minus 5 is 5. Now we're going to put these together. We're adding the logarithms, so we multiply the arguments. So 20 times 5 is 100, and common log of 100 is 2. 2 equals 2, so x equals 10. That's a good solution. We like it. Let's check x equals negative 5. All right, plug that in, negative 5 for x, negative 5 for x, right there. So we have common log of 2 times negative 5. 2 times negative 5 is negative 10. Plus common log of negative 5 minus 5, which is negative 10. And wait a second, we're taking the common logarithm of a negative number. We've got a negative argument, which is no good. It doesn't work. If you try to type that into your calculator, got it typed in there, and I hit enter, and it says non-real solution. We've got an error, and the calculator yells at us because it's no good. We can't do it. So negative 5 causes problems. So this doesn't work. We can't use negative 5. Our answer is just the x equals 10. And this is called an extraneous solution because it's a solution we get that doesn't work. It's extra. So no good. Alright. So there you go. You got to check these with logarithms. Make sure you have a positive argument. If you have negative arguments, it doesn't work. Undefined, non-real solution. Okay, what I want you to do is work out these 4 problems here. Pause the video, work these out, get your answers, come back, check it, see if you got them right. All right? So, go. All right, let's see how you did. 5, 6, 7, 8. That's what you should have gotten. If you did, congratulations, you're awesome. If not, let's check it out. You're still awesome, but here we go. So number 5, we have our original problem. And if you'll notice, these are both natural logarithms. So that means our base is e on both sides of the equation. So since our bases are the same, the arguments must also be the same. So we have 7x minus 4 equals 2x plus 11. So we subtract 2x from both sides, add 4 to both sides. We have 5x equals 15. Divide by 5, and x equals 3. X equals 3. Number 6. Number 6, we do not have logarithms on both sides. So what we're going to need to do here is get the logarithm by itself and write it as an exponent. Well, our logarithm's already by itself. So we just need to write this as an exponent. So the base of our exponent is the same as the base of the logarithm. Answer to the logarithm is the power for the exponent. Argument for the logarithm is the answer for the exponent. So we have 2 to the 5th equals x minus 6. Or we could exponentiate this whole thing using a base of 2. So we need to simplify that. That's a 2 to the 5th is 32. Add 6 to both sides, and x equals 38. Okay, so number 7, this is going to be a bit more work because we have two logarithms on the same side equal to some other number there. But they do both have the same base. They're both common logs, so they're both base 10, which means since we're adding the logarithms, we can multiply the arguments and make this one single logarithm. And we go ahead and distribute that in there. So that gives us common log of 5x squared minus 5x equals 2. Going to write this as an exponent now. So common log is base 10. So that's 10 squared equals 5x squared minus 5x. Well, 10 squared is 100. Set this equal to 0, put it in standard form. Now we're going to factor it. We can have a 5 we can factor out of that. So divide both sides by 5. And now we're going to factor that, which gives us x minus 5 times x plus 4. And the zero product property, this means our solutions are x equals 5 or x equals negative 4. We've got two solutions. Odds are one of these is not going to work. So we've got to plug these in and work them out. So plugging in the positive 5 times 5, 5 minus 1, plugging that in for x right here. Well, 5 times 5 is 25, 5 minus 1 is 4. Now I want to put these together, condense these logarithms into a single logarithm. So we're going to multiply the arguments. So 25 times 4 is 100. And write this as an exponent, this would be log base 10. So base 10 raised to the 2, so 10 squared equals 100, and yes it does. So 5 is a good answer. Now let's try negative 4. Plugging negative 4 in for the x's here. And let's see, 5 times negative 4 is negative 20. Negative 4 times minus 1 is negative 5. And uh-oh, we have negative arguments. So this doesn't work. It's going to be undefined, which means negative 4 is not a good solution, which is why our answer is only the x equals 5. All right. Let's take a look at number 8. So we have our original equation. We have logarithms that are the same base. Now they're not common log like it was here in the other example. It's base 4. But that's okay. They're the same base, so we can still work with this. We can still take these logarithms and put them together. So we're adding the logarithms. We need to multiply the arguments. So that's x plus 12 times x. Go ahead and distribute that in. And you know what? We've got this quadratic expression here again. So what do you want to bet we're going to have another set here where we have two solutions, right? So what I'm going to do is another way to solve these, another way to check these is you can solve these graphically. And it's really good when you're going to have two solutions. It saves a lot of time. When you have stuff like this, which is linear, that takes no time at all to work out. So we're going to put this graphically, but wait, we can't graph something that's log base 4. The calculator won't handle it. But we can use the change of base formula, change this into common log or natural log. And that's what I'm going to do. I'm going to use the change of base formula to change this into natural log. So that's natural log of the argument divided by natural log of the base equals 3. And now I'm going to put this in my calculator. Stick this into y equals. Remember, whatever's on the left goes in y1. Whatever's on the right goes in y2. And then we look for where these intersect. And sure enough, these only have one intersection, not two. So my answer is only the one solution right there, x equals 4. Another way you can solve this using the graph. And that is logarithmic equations. I hope you found this helpful, and see you next time.